to another episode of the MemcycoFM show. Imagine this for a second. Your most vigilant customer gets an MFA prompt, they type it in correctly, and they see your normal loading screen.
Right. Everything looks perfectly secure to them.
Everything looks fine, but in that exact millisecond, an attacker, maybe 3,000 miles away, just bypassed your $1 million security stack.
Yeah.
They hijacked the session, and they walked away with full access. I want to speak directly to you right now.
Sure.
If you are a CISO, or really anyone steering the security strategy for a modern digital business, you know exactly what the typical cybersecurity conversation sounds like today.
Oh, absolutely. It's usually this exhausting narrative about inevitability.
Right. This underlying idea that threats are just too sophisticated and, well, you're inevitably going to get breached.
Yeah, the doom and gloom approach.
Exactly. But we are tossing that script out the window today.
Yeah.
You are forward-thinking, you want to stay ahead of the curve, and you do not have time to be bogged down in a perpetual state of firefighting.
And that proactive mindset is, that's exactly what we need. The goal of a modern security architecture shouldn't be to just build higher walls and wait for the alarms to go off.
Yeah, playing defense forever.
Right. It's about gracefully preempting threats. It's about altering the economics of the attack and stopping the fire before a single spark even catches.
I love that. So today, our mission for this deep dive is to look at some incredibly compelling documentation from Memcyco. We are going to unpack how advanced account takeover attacks, ATOs, and man-in-the-middle tactics are actively bypassing the traditional defenses we've relied on for years.
Which is a huge blind spot for a lot of teams right now.
It really is. But more importantly, we're going to look at a highly effective, upbeat, solutions-oriented approach to effortlessly shutting these attackers down in real time. We're talking about taking control of the browser environment itself.
It's a total game changer.
It is. So let's start with the hard truth regarding the illusion of safety we get from multi-factor authentication.
Yeah, let's get into it, because MFA has been, it's been the great comfort blanket of enterprise security for over a decade now.
The ultimate silver bullet. Right?
Exactly. The conventional wisdom dictated that if you implement robust MFA, you are largely insulated from account takeovers. And the logic was sound back then.
Sure, because the idea was, even if a criminal compromises a database and steals a static password, it shouldn't matter.
Right, because they don't possess the user's physical device to retrieve that one-time passcode. But what the source material makes terrifyingly clear is that attackers have entirely evolved past the need to steal static passwords.
Wow.
Yeah, they're now capturing live credentials, session cookies, and OTPs in real time.
Okay, let me pause you right there because the mechanics of this are so crucial for our listeners.
Yeah.
If the attacker doesn't have the user's phone, and the user is the one typing the code into their own browser, how are the attackers intercepting that exact session?
That's the big question.
Are they somehow breaking the encryption in transit?
No, they aren't breaking the encryption at all. They are actually subverting the endpoint connection itself. What we are seeing is the massive proliferation of real-time phishing proxies.
Okay, like what kind of tools?
Tools like EvilJinx or Modlishka. Instead of building a static, fake login page that simply harvests a username and password and saves it to a database, which is the old way, the attacker sets up a dynamic reverse proxy server.
Oh, I see.
And this server sits directly between the victim and your legitimate authentication infrastructure.
So if I'm understanding this, I'm thinking of an analogy. It's like hiring the world's best bouncer for your club.
Right. Okay, yeah.
But the thief is standing right in front of him, taking the VIP's ID, handing it to the bouncer, and then walking right in.
That is exactly what it's like. The proxy essentially acts as a malicious router. The victim types their credentials into what they think is your site, but it's actually the proxy. Then the proxy instantly forwards those credentials to your real site. Your server evaluates the login, says, great, this is valid, here is the MFA challenge, and sends that prompt back.
Wait, so the legitimate server sends the real MFA prompt back to the attacker's proxy?
Yes. And the proxy receives the prompt and seamlessly renders it on the victim's screen. The user types in their code, the proxy grabs it, logs into the real account, and this is the critical part here, it captures the authenticated session cookie that your server issues upon a successful login.
Oh, wow. Okay, so the attacker doesn't even care about the password or the OTP itself at that point.
Not at all.
They just want that session token. Once they extract that cookie, they can inject it into their own browser, and they are fully authenticated as the user.
Precisely.
And from the customer's perspective, everything felt completely normal. They got an MFA prompt, they answered it, maybe the page hung for a split second, but the attacker already has the keys to the kingdom.
Yeah, the attacker acts as an invisible middleman. They seamlessly relay the conversation while quietly siphoning off the authentication tokens as they pass through.
This is wild.
It completely neutralizes the core value proposition of MFA because, well, the user is doing all the hard work of authenticating only to hand the resulting access directly to the adversary.
Right, but okay, if the proxy needs to sit between the user and our legitimate site, that implies the attacker has to force the user to route their traffic through that specific proxy server, right?
Yes, exactly.
You can't just spin up a reverse proxy and hope people magically decide to use it.
Yeah.
This requires some deep network layer deception. And the sources highlight a few ways they achieve this, starting with evil twin attacks.
Yeah, evil twins are a major vector for this.
Walk me through the mechanics of how an evil twin forces that routing.
So an evil twin attack exploits the way our devices naturally handle network discovery and trust. Think about a corporate executive working from an airport lounge or a hotel lobby.
Sure, happens all the time.
Right. Their laptop is constantly broadcasting probe requests, looking for known network SSIDs to auto-connect to. An attacker in that same physical space simply spins up a rogue wireless access point, broadcasting the exact same SSID as the legitimate hotel or lounge network.
Oh, I see. And because devices typically favor the strongest signal, the attacker just needs to physically position their rogue access point closer to the victim, or maybe broadcast at a higher power.
That's right. It's a purely physical advantage. Once the victim's device silently associates with the evil twin, the attacker controls the local network layer. They literally become the gateway.
Which means they control everything the user sees.
Exactly. From there, they can intercept DNS requests, manipulate routing tables, execute TLS stripping, you name it. They seamlessly downgrade secure HTTPS connections or serve up fraudulent certificates, instantly redirecting the user's intended traffic straight into those credential-stealing proxy sites we just discussed.
Okay, but if I'm a CISO listening to this, I'm thinking, well, an evil twin is a localized threat, right?
It is, yeah.
It requires physical proximity. And a highly vigilant user might notice certificate errors or recognize they aren't on their secure cellular data.
They might if they're really paying attention.
Right. But the sources highlight something much stealthier that scales globally, which is DNS poisoning. With an evil twin, you are tricking the Wi-Fi. But with DNS poisoning, you are fundamentally altering the browser's reality, aren't you?
You really are. You are corrupting the very routing logic that the internet relies on. When an attacker executes a successful DNS cache poisoning attack, whether that's by compromising a local router, a regional ISP cache, or, exploiting vulnerabilities in DNS infrastructure, they rewrite the A records.
Okay.
So when your customer types your perfectly legitimate, correctly spelled URL into their browser, the poisoned DNS infrastructure resolves that domain to the IP address of the attacker's reverse proxy rather than your actual server.
Wait, really? Which means the legitimate URL still appears in the browser's address bar.
Yes, it looks flawless.
There is no typo squatting, no weird hyphens. To the end user, and honestly to the endpoint operating system, the handshake looks entirely valid.
It looks valid because the browser is successfully communicating with the IP address it was given. The browser has absolutely no way of knowing the DNS response was forged upstream.
Let me ask you this then. As a CISO, if the URL looks perfectly fine to the user, aren't we basically asking our security stacks to fight invisible ghosts?
That is exactly what it feels like for security teams right now.
Because if the network itself is lying to the user's browser via poisoned DNS, the immediate instinct for a lot of security professionals is to lock down the transit layer.
Right, the knee-jerk reaction.
Yeah, the reaction is, well, this is exactly why we mandate VPNs for our remote workforce, or why we tell consumers to use secure tunnels on public Wi-Fi. But the Memcyco documentation addresses this misconception directly, doesn't it?
It does, and it's so important to clarify this. It is a pervasive myth that a virtual private network solves the man-in-the-middle problem entirely. A VPN is excellent for its intended purpose, which is encrypting the transit payload. It establishes a secure tunnel so that someone passively sniffing packets on a coffee shop Wi-Fi cannot read your data.
Right.
However, a VPN does absolutely nothing to validate the integrity of the destination or protect against browser-level manipulation.
Okay, let me use another analogy here, make sure I'm tracking this, because this is wild. If the DNS is poisoned, putting a VPN over that connection is like taking a beautifully armored car straight into an ambush.
Oh, I love that analogy, yes.
The vehicle itself is impenetrable during the drive, but the GPS has been hacked. You are just creating a highly secure, encrypted tunnel directly to the attacker's fraudulent proxy server. The transit is secure, but the destination is completely compromised.
That is an excellent way to frame it. The VPN secures the pipe, but it really doesn't care what is at the end of the pipe.
Right.
Furthermore, consider man-in-the-browser attacks. If malware has infected the browser itself via a malicious extension, it is altering transactions and capturing DOM inputs before the data is even encrypted and sent into the VPN tunnel.
Oh.
The VPN is entirely blind to what happens inside the browser's memory space.
Which naturally brings us to the operational reality for security teams.
Yeah.
Because if the URL looks correct to the user and the VPN is just blindly routing traffic to a poison destination, how does the enterprise actually know this is happening?
That's the million-dollar question.
We can't expect the customer to become our intrusion detection system and notice that a page took, 200 milliseconds longer to load.
No, of course not.
So security teams rely on logs. They pipe network telemetry and authentication logs into their SIEM. They apply threat intelligence frameworks, and they look for anomalies.
Right.
But there's a massive architectural flaw with that approach, isn't there?
There is. The flaw is latency, both technical and operational. Relying on post-transaction logs means you are fundamentally operating in the past. If you detect an anomaly in the session token usage or, say, a weird geographical jump in the IP logs, the session hijacking has already occurred. The authenticated cookie has been exfiltrated, and the fraudulent transaction has likely already been initiated.
You are investigating a crime scene, not preventing a crime.
Exactly.
And from a metric standpoint, your mean time to detection, your MTTD, is mathematically always going to be greater than 0. You are constantly playing catch-up, trying to revoke tokens after the adversary has already gained a foothold.
Exactly. Traditional network perimeters and post-incident log analyses are fundamentally mismatched for this specific threat vector.
Yeah.
Because the proxy attack happens dynamically in the browser, manipulating the real-time interaction between the client and the application, the defense mechanism must live exactly where the attack happens. It has to be in the browser, evaluating the context in real time.
And this is where we see the massive paradigm shift introduced by Memcyco's approach. Instead of relying on network choke points or analyzing stale logs, they focus on preemptive, real-time intervention directly at the point of interception.
Right, which is huge.
But let me push back on this for a second, because I know what our listeners are thinking. The documentation emphasizes that Memcyco provides an agentless solution.
Yes.
If we are talking about gaining deep visibility into browser-level attacks on unmanaged personal devices, like a retail customer's home laptop, how is an agentless deployment actually possible? We can't force millions of e-commerce shoppers to download a security plugin. How do you get browser telemetry without an agent?
It's a really brilliant application of server-side integration combined with client-side execution. You aren't asking the user to install anything at all.
Yeah.
Instead, Memcyco's technology is embedded into the legitimate application's web code at the origin server. When a user requests your web page, that telemetry script is served alongside your HTML and JavaScript.
Oh, okay. So it runs dynamically within the document object model, the DOM of the browser for that specific session.
Precisely. Now think about what happens during a real-time phishing proxy attack. The attacker's reverse proxy pulls your legitimate site's code to render it for the victim, right?
Yeah.
Well, in doing so, the proxy unknowingly pulls and serves the Memcyco telemetry script as well.
Oh, that's fascinating. The attacker's own infrastructure delivers the countermeasure to the victim. It's like hiding a digital die pack inside the authentication flow.
That's exactly how it works. Once that code executes in the victim's browser, it wakes up and assesses its environment. It immediately detects the subtle environmental mismatches that characterize a proxy or an evil twin.
Like what kind of mismatches?
It recognizes if the domain rendering the page doesn't match the origin, or if the DOM has been tampered with to inject keyloggers. The moment it detects this manipulation, it signals the legitimate origin server via a secure out-of-band channel.
So the origin server gets an instant alert saying, hey, the session token you're about to issue for this login, it's currently being routed through a hostile proxy. Do not trust it.
Yep.
And the enterprise can instantly terminate the handshake before the token is even generated.
Yes. That is what allows organizations to achieve a mean time to detection of literal 0. The detection happens at the precise inception of the attack, allowing you to drop the connection before the compromise is finalized.
But let me ask the question. Every CISO is screaming at their dashboard right now, false positives.
Ah, yes.
If we are auto-blocking transactions in real time based on client-side browser telemetry, how do we ensure we aren't accidentally locking out legitimate customers?
Yeah.
I mean, what if they're just using a weird ad blocker or a privacy-focused browser extension that alters the DOM?
It's a critical operational concern, and it's exactly why the telemetry has to be highly deterministic. Memcyco's engine isn't just looking for generic weirdness. It is analyzing specific cryptographic proofs and structural behaviors that are unique to man-in-the-middle relays and proxy infrastructure. A standard ad blocker modifies the DOM to hide a div tag. A phishing proxy manipulates the session architecture and routing headers.
Got it.
The telemetry distinguishes between a user customizing their local view and an adversary actively intercepting the authentication pipeline. This high fidelity is what gives security teams the confidence to actually automate the blocking.
So we've established how the technology bypasses the friction of agents and effectively uses the attacker's own proxy against them. Let's shift to the operational impact.
Let's do it.
We know the mechanics, but what is the actual return on investment? When an enterprise moves from investigating logs to proactive browser protection, what do the hard numbers look like for the business?
The proven impact detailed in the source material is deeply compelling. By implementing these advanced MitM countermeasures, organizations are observing a reduction in account takeovers by at least 50%.
Wow, half of your ATO volume just completely eliminated. Think about the cascading benefits of that.
The downstream effects are massive. Because you have reduced that mean time to detection to 0, you are slashing incident-related expenses by millions of dollars.
Yeah, I bet.
Your security operations center is no longer burning hundreds of labor hours doing forensic analysis on hijacked accounts. You are avoiding the cost of customer compensation, you're mitigating regulatory fines for data exposure, and you're skipping the agonizing process of breach notifications entirely.
And what's really striking in the documentation is that stopping reverse proxies and standard ATOs is just the tip of the iceberg.
Oh, for sure.
Once you have this secure, deterministic visibility into the actual digital journey of the browser, Memcyco's agentless shift solves a whole spectrum of adjacent threats. Let's take a look at one of the more insidious ones: brand impersonation and SEO poisoning.
That is a fantastic use case to highlight. Traditionally, brand impersonation has been incredibly difficult to police. Attackers build a fake e-commerce site that visually clones your brand, and then they manipulate search engine algorithms, SEO poisoning, to push their fake site to the top of Google results.
Right. So a customer searches for your brand, clicks the top link, and interacts with the fraudulent site.
Exactly.
And historically, the enterprise has no idea this is happening until angry customers start calling customer service, wondering why their credit cards were charged, but their products never arrived.
Right, because you are totally blind since the traffic never even hit your servers.
So how does browser-level telemetry solve a problem that happens entirely on attacker-controlled infrastructure?
It goes back to how attackers build these sites.
Yeah.
To make the clone look convincing, they don't redraw your logos and rewrite your CSS from scratch.
No, they're too lazy for that.
Right. They dynamically scrape your live visual assets, or they proxy your front end. When they do that, they inadvertently pull the embedded Memcyco watermark.
So the moment the victim loads the fake site from the poisoned Google search, the telemetry script executes. It realizes, wait a minute, I am rendering the official brand assets, but I am sitting on a completely fraudulent domain.
Exactly. It instantly alerts the enterprise security team, pinpointing the exact URL of the fraudulent site and the infrastructure hosting it.
That is amazing.
You get immediate real-time intelligence on brand impersonation campaigns the second a victim interacts with them, allowing you to initiate takedowns rapidly rather than waiting weeks to discover the fraud through customer complaints.
It's just brilliant. And it covers fake e-shops, remote desktop takeovers where fraudsters exploit remote access tools during legitimate sessions, credential stuffing detecting it faster than server-based rate limiting, and even protecting academic intellectual property or ensuring charity donations aren't diverted. It really highlights the versatility of the solution.
What's fascinating here is the underlying philosophy of this approach. This isn't just about deploying a technical countermeasure against a specific exploit like Evil Jinx. It is about fundamentally preserving the ultimate trust in the digital journey.
Right.
If a customer clicks your link, searches for your brand, or authenticates into your portal, they need an absolute guarantee they are interacting with you and only you.
You are shifting from a passive defense posture to an active one. You aren't just waiting to receive clean traffic. You are projecting your security perimeter out into the unmanaged browser, actively deceiving the threat actors and shutting down their infrastructure at the point of contact.
Which brings us to a strategic pivot for how security leaders should view their operational model. If we connect this back to the core responsibilities of a ISO, this raises an incredibly important question for you to mull over as we wrap up.
Let's hear it.
If you can reliably reduce your mean time to detection to literal zero at the browser level, how does that shift the way you allocate your security budget?
Now, that is the multi-million-dollar question.
It truly is. When you no longer have to stockpile capital to pay for the cleanup of post-compromise breaches, when you aren't spending massive portions of your budget on incident response retainers and crisis management for hijacked sessions, where will you invest that reclaimed capital?
Yeah.
You finally have the opportunity to transition your budget from reactive damage control to proactive initiatives that drive actual business value and seamless customer experiences.
That is exactly the kind of strategic advantage we love to uncover on this show. It's not about spending more. It's about spending smarter, fundamentally altering the architecture of the engagement and taking the structural advantage away from the attackers.
Beautifully said.
If you are dealing with the growing headache of reverse proxies, ATOs, or if you simply want to see the mechanics of agentless real-time protection in action, I highly encourage you to book a custom demo with Memcyco. It's a completely non-salesy, deeply technical look at how this works.
I highly recommend it.
Seeing the solution actively identify individual scam victims and disarm threat actors in real time is an absolute game changer for your security stack. You can find more information and request that demo directly through their resources. Thank you so much for joining us for this deep dive. You don't have to keep fighting invisible ghosts when you finally have the tools to turn the lights on. Until next time.